Hello everyone, today I will show us questions. I think this question is a little classical, just like this question. There is a belt that has a constant velocity 2 meters per second, as shown below. From A to B is 10 meters. Now we put 1 kg object without internal velocity on A. It needs 6 seconds to arrive B. Determine the belt minimum velocity when it needs minimum time to transit an object from A to B. Just like this diagram. The question asked me to need minimum time to transit the object from A to B. So I think if this object needs a minimum time, it must accelerate in this whole progress. But the question needs us to determine the belt minimum velocity. So this object from A to B is accelerate, and from B to the end, it will have a constant velocity. But this constant velocity will same with the belt. And in this case, this object's acceleration is unchangeable because this acceleration just be given by friction, and the friction will not change. If we want to calculate the object m velocity from when it arrives B, so this velocity will the belt's minimum velocity. So we just write the velocity equations. Next, welcome to my partner haoran to help us to write this question. VB squared equals to VA squared plus 2AS. In this question, we can know VA squared is equals to 0, S is equals to 10 meters. So VB squared equals to 0 plus 2A10. So in this equation, we don't know the acceleration. So in the step 2, we just need to calculate the acceleration. This question can be solved. Now we don't use the questions give us some figure. In this question, he put 1 kg object without internal velocity on A. It needs 6 seconds to arrive B. In this question, there are two situations. One situation is from A to B, the object is accelerate in this A to B progress all time. And another situation is A accelerates in this progress, and in some times he will have the same velocity with the belt to have consistent to the B. In the situation 1, we can write some equations just like S equals to VAT plus half T squared. The S in the first situation, it must be 10, and the VA is 0. So we can write 10 equals to 0 plus half A6 squared. So we can solve this acceleration. The A must equals to calculate it must be 0.6 meters per second squared. So we solve this acceleration, but we need to test it is possible. So if this A is equals to 0.6 meters per second, so when he arrives B, his velocity must be, we can write another equation, VB equals to VA plus AT. We can calculate the VB. VB equals to 0 plus 0.6 times 6 So VB equals to some 3.6 meter per second. So we can say 3.6 meter per second over the question given me 2 meter per second. So I think it's impossible because we cannot bigger than the belt velocity. So I think this situation is impossible. Now we can try to the situation 2. In the situation 2, the object has accelerate and then has a constant velocity as belt velocity to arrive B. In this case, we can assume this object stop here. From here to B will have a constant velocity, and from A to this point, it will have a average velocity. This average velocity must be VA plus 2 meter per second divided by 2. So this we can but also we know VA is equals to 0. So the average velocity is equals to 1 meter per second. Meter per second. So we know this average velocity in this part will be 1 meter per second. So this distance will be 1 meter per second times 1 meter per second times t. So in the after part, it will have 2 meter per second to the B. So in this in here the distance will be 2 meter per second times 6 minus t bracket. This is the first distance, and this is another distance. The two distance addition must be 10 meters. So 1 plus this equation must be 1 meters. So we can solve the t. 1 plus 2 times bracket 6 minus t it equals to 10 meter. We can solve the t, and if we know the t, we can continue to solve the acceleration. In in here, from A to this point, the velocity will change from 0 to 2 meters. So we also can write another equations. V equals to VA plus AT. VA is equals to 0, so V equals to 0 plus AT. We use these two equations, so we can calculate the A equals to 1 meter per second square. A equals to 1 meter per second square. So this is a possible situation. So we just use this A equals to 1 meter per second. Some in these questions we just can calculate the VB. The VB is equals to 4.5 meter per second. So all these questions answers. I think these questions is some classical. So I hope us can